Good morning, sir. Today, our group are going to present our topic, Smart Bed System. Our group members have Owaini, Wong Yun Tak, Yap Yu Kang, and me, Wong Jing Yi. And we are going to start our presentation now. And now I will present for my part, introductions. Smart Bed System is an IoT-based solution which help users improve their sleeping quality and regulate their health while they are sleeping. The system includes a variety of sensors such as temperature sensor, pressure sensor, heart rate sensor, and others for monitoring user sleeping and healthy condition while sleeping. Nowadays, smart bed systems become popular and used in a variety of settings from home to hospital. Smart bed system expected to continue to evolve and expand in the coming years. That's all from me. Thank you.
The problem statement of our proposed system is the sleep quality can be determined by tracking the sleep duration of the user. If the user sleeps greater than 7 hours per day, then the sleep quality of the user can be considered as good, otherwise it's poor. Proposed sleep quality mainly due to the stress and the anxiety of user. So if the user feels stressed at the day, then it will sleep below than 7 hours at the day. So the poor sleep quality may cause high blood pressure and heart disease. Thus, it's important to have a good sleep quality. So the objective of our project is to develop a system that can track the sleep duration of the user and also develop a system that can measure the sleep quality of the user based on the sleep duration. And the third objective of our project is to develop a system that can notify users when they have a poor sleep quality. In order to connect a device into the cloud, we have to create a thing in the IoT cloud as our device. So in the list, we can see that I have created a sensor as our device in the thing. So after create the device, after create the things, so it will generate a certificate file, the private key and the public key, and also the CA file. So we have to download all this file and put it in the folder, and then we have successfully created the thing. And now I have created a Python file to generate a random data. So in the Python file, we will put in the endpoint, the certificate file, the private key, and also the root CA. And then in the file, I will connect to the MQTT client and then start to publish the data I need to use it later. And then we can go to the MQTT test client and we have to subscribe the topic. So my topic is called My Sensor, and then subscribe the topic and run the Python file in the terminal. It may take some time to run it. All right, we can show the publish end, so therefore we can see the data in this page. So this is the data generated, and then we can see the data will also send it to the S3 also. Since I have configured the rules, so this is the data I generated just now. So we can download to see the file content. We can see the file content is same as the data just now. We can prove that the data uploaded to the things, and then it will successfully publish to the MQTT and store it in the S3.
So for the continue part is S3. So when S3 get the sensor data, it will trigger the function of the Lambda, which is put object 2. when there's a record stored inside here, it will trigger this lambda function. The lambda function is then will process the data and calculate the duration of the user sleep for that night. So this is the code of my lambda function. So it will first get the data from the file from a sensor data bucket. After that, it will check whether the object is exists in S3. If exists, the file will not create, and it will directly append the record into the bucket. If the file does not exist, it will create a new file to store the record. And this is the code to get the times in the record. And this is the code to calculate the duration of the user sleeps and upload to the file inside the new bucket, which is known as test bucket. So this is the overall code. So we press test to test the function. So the time difference between the duration of the user sleep is 0.0 is 22 seconds. So it will print out a put complete, which means that the data is being stored inside the S3. So now we can see in the S3 that the test bucket will have a result.json which store the process data. So now we download and we can see the data inside the JSON file. So this is the data that's stored inside here, which means this have two records inside this JSON file. So that's all for me. Thank you.
Hi everyone, my name is Yap Kang, and now I will be continuing with the AWS SageMaker. So once the process data has been passed into the S3 bucket called sensors.data, and then we will continue with the SageMaker to predict the sleep quality of the user. So now let me open the Jupyter, and it will be linked into this page. Then we will open the notebook called prediction. So the first code is the function that will calculate the sleep quality. The measurement of the sleep quality is based on the sleep duration. And if the sleep duration is more than 7 hours, then we will classify it as good. And the sleep duration that is less than 7 hours will be classified as bad sleep quality. Next, the next part is to read the input data from S3. And this is the name of the S3. And then we will run the function that we have created earlier. Then we will continue to pre-process the data, and then we will split it into X and Y. The next part of the code is to split the X and Y into train and test set. Then we will define the row and region. Then we will combine the X train and Y train into one train data frame and change it into CSV file. Then we will upload the train.csv to S3 so that it will be used in later for train input. Then we will define the hyperparameter for the model that we are training, which is logistic regression. Next, we will start to create the training job and start to train the LR model. So once the training job is finished, it will be shows output something like this. Then we will continue. Once it is completed, we will deploy the model to an endpoint. Then we will instantiate the predictor and set the content type so that the input data can be read by the model. Then we will start to predict the model. So once we have predict the model, then we will finish the prediction. Then we will compute the accuracy of the model, and the accuracy is 98.75%. Last but not least, we will save the prediction result along with the input features into a new CSV file, and we will upload it into S3 for QuickSight later. And this is the sample. This is the output result of the CSV looks like. And the S3 will be passed into here. Yeah. And that's all from my part. Thank you.
Okay, now I will talk about the AWS SNS. At first, we need to create the topic, and I have already created a topic, IoT data topics. And next, when click in, and then we need to click the create subscriptions, and then to set the endpoint for us, and for me, I will set this Gmail. Okay, now I will talk about the Lambda. For this Lambda, right, the code will be retrieve the data file from which is trained by the SageMaker from the S3, and then it will read the data file, and may detect the sleep quality is less than 1, this means 0, and then it will publish the data to the SNS topic. And now we will try it, and now I click test. It shows success, and now we go to our email. And you will see we receive the AWS notifications message. All the data will be sent to the user through the email. That's all from me.
In the QuickSight, we will create a new analysis and create a new data set. We will read the data from the S3, so we choose the S3 and simply enter a name for the data source and then upload the manifest file. And click connect. And edit the preview data. So it will read the data from the S3 and it will display this view of data. So after processing the data, the data visualization will show like this. So the user can see the duration and the sleep quality of them based on the date. And also they can see in the same day the several user, their sleep duration and also the sleep quality. And also in the same day, they can see how many people getting a poor sleep quality and how many people getting a good sleep quality. So that's all for QuickSight.
Okay, now I will talk about the Amazon Cognito, and we need to create a user pool, and we already create, so I will just show it, user 1, and then here we will go to the app integrations, and then we need to go to the app clients. This is to let us go to the pre-built hosted UI. We click it, view hosted UI, and then the Cognito will bring us to here. And if you didn't have the account, you need to create a new one. So I just randomly put a name, and then give the account the Gmail, the password, and sign out. And then a verification code will be sent to the email. And then to paste it and confirm account. And it will just bring us to the callback URL we just provided, because as our group didn't create a website or mobile app, so I will just randomly put a URL for the callback. So that's all from our group. Thank you.